Hi, this is Zixuanjia's project Retrospective, and here is my basic version of knowledge graph for University of Washington. Here I just simply connected the web pages according to Wikipedia. So for the first question, describe how Wikipedia can be used to construct a knowledge graph. So my answer to this is Wikipedia's pages for a topic will always provide links to other related topics. Therefore, it can be used to figure out the connections between pages provided by the project. For example, page University of Washington contains the link to Anna Mary Coss in the part of governance, and contains the link to Seattle in the part of location. On the other hand, page Anna Mary Coss and page Seattle also contains the link to University of Washington. So I have two pictures of Wikipedia. Firstly is the page University of Washington, and I found Seattle's link in this page. And also from Seattle's link, I found Seattle's page, I found the University of Washington's link in it. Therefore, according to Wikipedia, I can easily find the connections between pages. And then for the second question, it asks to describe a knowledge graph algorithm for resolving a search query for UW to University of Washington. So firstly, we are given a keyword UW, and then the user is physically in Seattle. So firstly, what we should do is to convert this phrase to a single keyword Seattle. Then our query simplified to two keywords, UW and Seattle. And then from the page UW, we see a lot of universities can be represented by UW. There's University of Washington and University of Wisconsin-Madison and other universities. So the first method, we can just traverse through all nodes related to UW and trying to find a node containing Seattle. But this will probably take a really long time since we need to traverse all the nodes in the page UW and then all the nodes for every universities. Therefore, considering the time complexity, we can group the pages related to University of Washington and for other universities. Seattle should belong to a group called location. And here's my improved version of knowledge graph. I used extra nodes for grouping the pages. And then I grouped the related node to its different groups. And then for this case, this part of the nodes will not be gone over since they are not related to location, then it's actually saves time. According to this, I got a complete version knowledge graph for University of Washington. And here I add the extra nodes to it. But it's worth to mention that different knowledge graphs may exist for different web pages. This one is kind of only for University of Washington. So for the third question, describe how knowledge graph could be used to compute following answers. So firstly, for President UW, here before computing President UW, we need to solve the problem with multiple keywords. And my method to this is to create priority to the keyword to represent how specific it is the keywords. So, for example, more specific keywords may have less connected nodes to it. Therefore, it is good for time complexity. And in this problem, I will assume that priority is based on the number of links in Wikipedia page. So more link it contains, it may have lower priority because for the time complexity, if we start from the fewer ones, then we can compute quickly, more quickly. Also, I assume that actual pages are considered more specific than disambiguation pages like UW. And then we can create priority queue to figure out the order for keyword to look at. Therefore, UW in this case is more specific than president, so we search UW before president. And then since we computed UW to University of Washington in the previous question, so we now can easily use University of Washington. And then we search for presidents in University of Washington. And we find a category presidents under University of Washington. But we cannot simply return this node because this is not an actual valid node. This one does not represent a real web page, it's just a grouping node. So we, from the category presidents, return Anna Mary Cos here. And that's how we compute President UW. So for computing President Washington, we start from the keyword president, since president page has less links in Wikipedia. And then from the related pages to presidents, we find the node George Washington. And in this case, there may exist other President Washington, but I didn't see them by searching President Washington in Wikipedia. Therefore, for this case, I will just assume that there is only one President Washington under the President page. So if there exists more President Washington, then priority queues may help solve this problem in this case. Okay, so then we just return George Washington from the page president. And that's how we compute President Washington. Then finally, to compute president. Because only one president's keyword is too weak to get the output Joe Biden. Therefore, I think we probably need to have a default location on the knowledge graph when there is no other keywords. So in this case, I set the default location to be the United States. And then from the page United States, we find the category president, like how we search President UW in the first question. And then we just simply return Joe Biden in the president category of the United States page. And for the last problem, we are given a rule that if there are multiple sources for an idea, choose the idea that appears the most often among the sources because this represents the consensus. But there are problems to this rule. One of the problems is that consensus doesn't always represent the truth. For example, people always love to say that goldfish only have few seconds memory time. People use it in daily life and also in their literature works to express their feeling. And this results in a more often appearance of few seconds. However, the truth is goldfish can actually remember things for at least several months. And this will actually harm the society because if a young children trying to search goldfish memory time, they will get wrong answers, and this will lead to misunderstandings to goldfish and actually the fact of the world. Okay, so what I represented as the next step is to redesign the algorithm. Firstly, you can apply priority to the web pages. Priority may be calculated based on authority and consensus. And authority should weigh more because authorities will more likely get the truth. And then in this case, web pages that have both high authority and consensus will have higher priority. And then web pages that have high authority will have higher priority than the one that only have high consensus. And by this way, we can apply priority queues to help find the one that have highest priority or figure out the order of results. And by this way, we can somehow fix the problem with misunderstanding. And then our algorithm will more likely to return the true answer to the query. And that's all. Thank you.